Assalamu alaikum, everyone. Welcome to Ahmad Farhan's solar system. Have you ever looked up at the night sky and wondered exactly what lies beyond our own planet? Well, today we are going on an incredible journey right through our solar system to discover some amazing worlds and, honestly, some pretty mind-blowing space facts. We're going to be traveling through a cosmic neighborhood that formed about 4.6 billion years ago from a huge cloud of gas and dust.
But before we launch, let's subvert some expectations right out of the gate. Most people assume that the closer you are to a fire, the hotter you get, right? So Mercury absolutely has to be the hottest planet. And when we picture Saturn, we always picture its iconic rings. But what if I told you that our solar system isn't just some static, unchanging museum exhibit? It's actually this wildly dynamic, ever-evolving place where the closest planet isn't the hottest. And Saturn's rings? They're actually on a ticking clock.
So here's a great look at our cosmic neighborhood. Everything you see here orbits the sun, which sits right smack in the center. As we blast off today, we'll use this layout to orient ourselves, traveling from that massive burning star in the middle all the way out to the freezing dark edges of our planetary neighborhood.
And here's our flight plan for today's explainer. First, the Sun and solar mechanics. Second, Mercury and the hottest planet Venus. Third, Mars and robotic exploration. Fourth, Jupiter's great red spot. Fifth, Saturn's young ephemeral rings. And finally, number 6, exploring the outer limits. Let's get to it.
Section 1. The Sun and Solar Mechanics. The center of it all.
Now, the Sun is a massive star, basically a giant ball of burning gases that provides the exact heat and light we need to sustain life here on Earth. But, its light isn't its only reach. The Sun's gravitational pull is literally the invisible anchor of our entire solar system. It totally governs the motion of all these celestial bodies. Without this massive gravitational force keeping the planets on their unique paths, everything would just drift away into the dark expanse of space.
As we move outward from the Sun, our system neatly divides into 2 main categories. First, we have the 4 inner planets: Mercury, Venus, Earth, and Mars. These guys are the small, rocky worlds. Then, separated by the asteroid belt, we have the 4 outer planets: Jupiter, Saturn, Uranus, and Neptune. And these are massive gas and ice giants with incredibly powerful atmospheres.
Moving on to Section 2. Mercury and hottest planet Venus, the extreme inner worlds.
So, the general rule of thumb is usually this: the further you travel from the Sun, the colder the planetary surface gets, right? Earth sits at a very comfortable 59 degrees Fahrenheit, Mars drops to a chilly -85, and Jupiter is a freezing -166. But then there's a glaring anomaly. Mercury, the closest planet, averages 333 degrees, but Venus, the second planet, is a staggering 867 degrees Fahrenheit. How on Earth, or rather how in space, is the second planet hotter than the first?
Well, the answer is a runaway greenhouse effect. You see, Venus has a very thick atmosphere made of dense carbon dioxide that acts like a giant blanket. Billions of years ago, Venus might have actually had liquid water, but as the sun warmed the ground, that CO2 trapped the heat. The oceans evaporated into water vapor, which is an even stronger greenhouse gas, by the way, and that accelerated the heating until it got so incredibly hot that carbon actually sublimated right out of the rocks. Today, that atmosphere is 92 times as dense as Earth's. It traps heat so intensely, it could literally melt lead.
Now, let's jump back to Mercury. It might not be the hottest, but it has its own massive surprises. Because it has no real atmosphere to trap heat, its temperatures swing wildly between day and night. But get this, data from NASA's Messenger mission revealed something crazy. Mercury's inner solid core makes up a shocking 85% of the planet's volume. Compare that to Earth's core, which is just 15%. Plus, despite being so close to the Sun, Mercury actually has water ice hidden in these permanently shadowed craters near its poles. It's just a completely enigmatic little world.
All right, Section 3. Mars and robotic exploration. The red planet.
Skipping past our beautiful home Earth, which, of course, is the only planet we know of sitting in that perfect Goldilocks zone with liquid water and oxygen, we arrive at Mars. The red planet is this frozen, rusty world that scientists believe may have once harbored water and potentially even life. To uncover those possibilities, NASA uses incredibly sophisticated robotic explorers. We have the Perseverance rover, which is busy collecting samples for a future return mission to Earth. There's Curiosity, investigating past microbial habitability.
And zooming around from above, the Mars Reconnaissance Orbiter and Mars Odyssey are mapping the terrain, the atmosphere, and the global chemical makeup. It is a busy, robotic frontier, all preparing for future human missions.
Section 4. Jupiter's Great Red Spot, the solar system's largest storm.
Crossing the asteroid belt, we reach Jupiter. This is the largest planet in our solar system, a true gas giant defined by its incredibly powerful storms. The most famous of these, without a doubt, is the Great Red Spot. It's a massive anticyclonic storm, churning at speeds up to 496 kilometers per hour. But what's truly fascinating is the temperature up there, 1600 Kelvin. Infrared data shows that the upper atmosphere directly above the Great Red Spot is hundreds of degrees warmer than the rest of the planet at that same altitude. Scientists think this incredible heat is caused by acoustic waves rising from the storm's turbulence and then breaking in the upper atmosphere, kind of like ocean waves crashing on a beach.
And we've actually been watching this colossal storm for a long time. The first continuously recorded observation goes way back to 1831, and we have learned so much since then. More recently, the Juno spacecraft mission, which entered orbit in 2016, flew just 8,000 kilometers over the Great Red Spot in 2017. It used microwave radiometers to probe deep into the storm structure. It's a swirling, violent mystery that we're finally starting to peel back.
Section 5. Saturn's young ephemeral rings, a temporary wonder.
Okay, this brings us back to the question we asked at the very beginning of this explainer. Recent studies from NASA's Ames Research Center, using data from the Cassini mission, proved that Saturn's rings are actually young and ephemeral. They're made almost entirely of pure ice and rock, but they're constantly being bombarded and polluted by non-icy micrometeoroids. By calculating exactly how fast this cosmic hailstorm of debris is contaminating them, scientists realized the rings have only been around for a tiny fraction of the solar system's 4.6 billion-year life. Think about this. During the time of the dinosaurs, Saturn might not have even had its rings yet. And, crazy enough, they might only last another few 100 million years.
Finally, Section 6. Exploring the outer limits, the ice giants, and beyond.
Out here at the edge, the temperatures absolutely plummet. Uranus sits at a biting negative 320 degrees Fahrenheit. And it's totally unique because it actually rotates completely on its side. Then we have Neptune at negative 330 degrees, where we've recorded some of the absolute fastest winds in the entire solar system. And pushing even further into the Kuiper Belt, which is a vast region filled with icy objects, we find dwarf planets like Pluto, dropping all the way down to negative 375 degrees Fahrenheit.
To wrap up our journey, exploring space doesn't just help us understand our universe. It gives us profound perspective. Our dynamic 4.6 billion-year-old solar system is really just one tiny corner of the Milky Way galaxy. With billions of other stars out there, you have to wonder, what other incredible, extreme worlds are waiting to be discovered? Thank you so much for joining me on this amazing journey through space. If you enjoyed this explainer, please like, share, and subscribe to Ahmad Farhan Solar System for more exciting space adventures. Keep looking up, and I'll see you in the next explainer.